Hi, everybody. So thank you for attending my talk today. My name's Tom Ward. I am a Chief Technical Architect at Westbrook, which is a Platinum partner in the UK. And what I want to talk to you today about is programming with Lightning. Lightning has been a bit of a hobby of mine for probably the last year, 18 months. Obviously, there's been several key announcements over the last couple of Dreamforces about Lightning. And I think everyone here is probably interested in what that means for the platform and where it's going to take us. And my perspective on that is Lightning is going to be incredibly important as a developer, as an architect. All the kind of projects we're going to deliver in the future are all going to be built on Lightning. So we need to be prepared. And as part of that, I've been researching Lightning, building my own apps. And what I'm hoping to do today is share some of what I've learned over the last 18 months with you, so that hopefully you can build some apps, and this time next year we'll have a whole collection of awesome apps that you've all built and can demonstrate also. So what am I going to talk about today? So I really want to put it into context. So what I've done is I've built a component to demonstrate, and this component is going to show you all of these techniques in action, so that hopefully you can see how they can be used, why you might want to use them, and how you can create powerful Lightning components with them. The component I'm going to show you is a scheduling component, so it's going to help schedule jobs within a Salesforce org. And the techniques that I'm going to talk about are composition using facets, event bubbling and dynamic creation of event handlers, dynamic creation of Lightning components, and then how we use object-oriented design with Lightning. So with that, I'd like to introduce the scheduling component. So this component really is the fruit of many projects that I've worked on, where they've generally consisted of a lot of scheduled jobs in an org, and it's quite painful to have to manage those using anonymous Apex to set them up and take them down, particularly in development environments where developers are constantly making changes to classes that are referenced by the scheduled jobs. And every time they want to commit those changes, they've got to take all those jobs offline and then recreate them. Furthermore, the actual scheduling of the job itself, the actual when it should run, is all specified using a Cron expression. I'll talk a little bit more about that on the next slide, but suffice to say, these aren't really sort of admin friendly. Myself included, I often found I had to go to the developer guide and do a bit of research as to how to set up that expression to get the desired results. So I thought if I could build a tool that made that easier, both for a developer and for an admin, that's got to be good all around. So without further ado, let's actually, one last thing. Let's talk about the Cron expression. So the Cron expression is basically tells us when the job should run. As mentioned, these things can be pretty hard to write. As you can see, they basically consist of sort of numbers, symbols, and to the uninitiated, it probably doesn't make a lot of sense. The Cron, as this slide says, the name Cron is a Greek word for time, so it's unsurprising that a Cron expression is essentially the schedule for when the job runs. So let's go into a demo. So this is the component, and it's basically running inside just a demonstration app. And what you're seeing in front of you there is a list of jobs that are running in my developer org. And these jobs are being stored in a custom object, so that they persist whenever you sort of turn them off or turn them on. And in that way, we can basically create a list of jobs that we want and tie them to the classes that we want to run and set up the expressions. Now, if I was to click on the Add button, this basically pops open a modal, which will allow us to define what the job does. So we give it a name so that we can identify it. We specify the class. And then the bit in gray in the middle here is basically where we define the expression. And these tabs at the bottom basically help us set that up. So as you'll see, we've got tab for seconds, minutes, hours, days, so on. And these range in complexity from very simple, like seconds and minutes, where we're just choosing from a range of values, say 38 seconds, to the slightly more complex, things like hours, where we can express it as, say, every hour, on selected hours or on an interval. So let's just show you what that looks like. So if I'm on selected hours, then I get to choose from these options. Or interval where I might say it starts at 2 a.m. and then I want it to run, I don't know, every 3 hours. To slightly more complex ones like, let's say, days or weekdays, where we have a few additional options that are not common to some of the other tabs, like on the last weekday of the month, for instance. And through that, we can basically set up this expression. Once those are saved, we can see them in the list, and we can use the functionality to basically start and stop those jobs. So if, for instance, I want to start these two jobs in the middle, I just select them, schedule, has a bit of a think, and those are now scheduled in my org. And as you can see, that's quite a simple but powerful tool for setting up and managing these jobs. So back to the slides. Let's get the right one. There we go. Let's go into detail about the techniques that we've used. So the first one that I want to talk about is composition using facets. And as this slide states, it's basically the act of combining parts or elements to form a whole. So what you want to be thinking about when you build your Lightning components is you want to be thinking about reuse and how you can assemble these components to create something larger. So what I've just demonstrated to you there, it's not one large component, it's several components acting together to form the whole. So let's see how facets can help with that. So the requirements for the tab list that you saw, which built the Cron expression, is that it should be able to contain one or more tabs, which we saw. It needs to maintain styling to indicate focus, and I'm using the Lightning design system to show that. And we need to fire events so that the larger component, the scheduled job component, basically knows when to change the expression builder that you're seeing in the sort of tab content panel. And it's important that the scheduled job component is what's controlling that. So as we navigate between the tabs, the edit scheduled job component is basically telling us what to do. So jumping into a bit of code here, what is a facet? So this is the tab list. And essentially, a facet is any attribute that's of type or a component. So what we're basically saying here is that we're going to inject a component inside of another one. So the tab list is just a container, and the tabs that sit inside it are going to be other Lightning components. And as you can see here, we've got an attribute called tabs. It's defined as Aura components. And then if we look a little bit further into the code, where I've highlighted there, you can see where it's referenced. And that's essentially where all the tabs are going to end up. We're injecting them into that location in the markup. Now, I also want to mention another facet that you get for free with every Lightning component, and that's the body. You don't need to declare this as an attribute. You always get it. And the body basically indicates where, when you define a component, say like the tab list, anything that's contained within the definition of that component that's not being mapped to one of the facets that are declared as attributes will end up where that body variable is referenced. And I'll show you that in a moment. We'll take a quick look at the tabs. So just skimming through this very quickly, but the tab is basically consists of a name, a label, whether it's in focus or not, and where it sits in terms of an index position. It can raise an event, which is a click, and the click is going to basically tell us, well, it's going to provide us with a means of controlling the focus. And then finally, this is the actual markup for the tab itself, and again is implemented using the design system. So let's put all of that together. So this is an extract from the edit scheduled job component. And this is where we define the tab list that we want to use to build the expressions. And inside of it, you'll see how we set the facets. So there's this special tag called Aura set, which is used to set a facet of a component, such as the tab list. And we basically declare which attribute we want to set, in this case tabs, and then nested inside the Aura set, we have all the tab components that we want to assign to it. So in this case, you can see components for seconds, minutes, hours, so on. And then below that, outside of the Aura set, we have a variable being assigned called tab content. And this is essentially going to be the expression builder that you saw in my demo. It's being controlled by the edit scheduled job component, and we'll see later in the slides how that's done. But essentially, this is what's been assigned to the body of the tab list. It's contained within the tab list definition. We're not using or a set, so anything by default that's not using or a set ends up in the body. So the next one that I want to talk about is event bubbling and dynamic creation of event handlers. So to recap on the types of events that we have in Lightning, we've got two flavors. We've got application events, and these basically follow a sort of publish-subscribe model where imagine a component, it raises an event, and it's basically shouting out to every other component in the application that something's happened. And all those other components get a chance to either listen to it or ignore it. The other type we've got are component events, and these are much more targeted. So a component event, when raised, will either be handled by the component that raised it itself, or it can be handled by any other component in the containment hierarchy. And a little bit more about what that means on the next slide, because I have to say that was something that didn't mean a lot to me when I first read it months ago. So let's take a look at that. So this is the edit scheduled job component. And the example I'm going to give is essentially clicking on one of these tabs. So I'm going to click on weekdays, and that's going to raise an event, the click event. And I don't want to handle that in the tab itself because the click event is going to be my primary means of controlling the focus on my tabs and also changing up the content on the tab panel. So that event is going to bubble up. And any guesses where it would go next? Well, when I first got into Lightning, my next guess would be that, well, tabs are contained in the tab list component, so surely the tab list component gets to intercept that and do something with it. But this is what containment hierarchy means. You'd be wrong if you thought that. And the reason is because it is the actual edit schedule job component that's providing the definition for both tab and tab list. So when we talk about a container component, the container is the component that provides the definition. So in this case, edit schedule job is the container for both tab list and tab. Now that presents us with a problem because, as I said, I want to control the focus of those tabs. And ideally, I don't really want every component that uses my tab list to have to implement the same logic, which will move the focus around. Ideally, that logic should sit in the tab list, and in that way, I'm not ending up with redundant code all over the place. So how do we do that? And there are two ways. So there is the way everything used to work in summer 16 and earlier, and they've actually provided quite a nice new feature in winter 17, which makes it a lot easier. Unfortunately, making this a little bit redundant, but what I want to show here is the alternative technique because it really demonstrates how you can dynamically create event handlers. So whilst the problem might change, you might still be able to leverage this solution in other situations. So let's take a look at that. In our tab list component, we basically, when we initialize, this is the method that's called when the component is set up, we're going to loop across each of our tabs that have been passed in, and we're going to add handlers to them. So in this instance, I've just highlighted two tabs, and this is the method that we're going to call. So every component has a method that's available called add handler. And this allows you to add an event handler to that component. Now, what are the parameters that are being passed into it? Well, there's three parameters. There's the event name. So if we want to capture an event, it's important that we give it, we set up a handler of the same name. So if we look at the tabs here, we can see that the register event is click. Therefore, it's important that the handler is called click. We then have the value provider, and the value provider is essentially the component which is going to contain the logic that handles the event. So in this case, we're passing in component, which is the tab list itself. So the tab list is going to handle this event. And we then have the action expression, and the expression is essentially telling us which method on the value provider is going to actually do the handling. So in this case, it's the handle click event. And hypothetically, what you're doing here, essentially, is adding handlers onto these tabs. Now, you're not going to see that in the code or anything, but that's essentially what's happening behind the scenes. And if you take a look at this, what we're doing now is we're adding an event handler to the child component, which is tab, but we're wiring up an event handler that's actually in the parent. And this allowed us to get around the rules of saying that the tab list couldn't intercept it, because actually, it's the tab that's intercepting the event, but it's the tab list which is providing the logic that handles it. So it was a little bit intricate in terms of setting up some wiring here, but it demonstrated that it was possible to handle an event inside of the intermediary components, if you like. Now, the good news is that there's a lot easier way to now do this. So just to demonstrate here, this is the click event, goes through the tab to the handle click. And this is the easier way. So in Winter 17, all of that can get replaced with one line, which is great. So this is the tab list. We're adding a handler directly to this component now, and we're saying it's a click event that we want to capture. We're saying it's the handle click event method that we want to handle that. And there's this new attribute called include facets. And basically, this will mean that this tab list as an intermediary component can now intercept that event and deal with it. So, you know, this had actually been on my wish list for a number of releases. And whilst it did kind of torpedo my presentation a little bit when I read this about a week ago, it's still nice to read about it and see that, you know, programming with Lightning is going to get even easier. So onto dynamic creation of Lightning components. And this refers to the creation of components when we need them, rather than in advance. And you might be wondering why you might want to do that. And I think the example I would relate is that if you were to build a really complex application consisting of many components, when that application initializes, it's going to have to pull all of those components down, it's going to have to set them all up, and that's going to take a lot of time. And the last thing you want to do is inflict an experience on the user where they're sitting with a little spinner going round for 30 seconds a minute whilst your application loads. Now, if you can distribute the loading of those components through the experience, then it's going to be much better for them. They're not going to get as annoyed with it. So that's what dynamic creation of Lightning components allows. It says, we'll create the components as we need them. And the perfect example, again, is the tab list. So if I was to say, click on the minutes, what I want is the tab panel, the content, to change up and show me the minute expression builder. So let's see how we do that. And it's with this method that's part of the $A global object, and the method is called create components. And it takes two arguments, the arguments being the components you want to create themselves, and also the callback function. And the callback function is the method that's going to take the newly created components and do something with them. Typically, you're going to be injecting them into the parent component, getting them to render on the page. Now, lifted straight from the help documentation, the example they provide here demonstrates how they're going to set up three components. So we've got two lots of Aura text, we've got a UI button, and sitting in those curly brackets after each of those is the attributes that we want to set. And then the last bit is the function, the callback function. Now, in this example, it's not doing anything with it. It's just telling you a little bit about what it does. So let's see that in action. So again, this is an extract from the edit scheduled job component. And this is the handler for the tab focus event. So as we switch between the tabs, the tab that gets the focus essentially gets handled here. And the one that I want to concentrate on is the minutes tab. I mean, they more or less all do something very similar. So what are we doing here? Well, there's a number of elements. We've got a helper method, so get minutes parameters. And this is basically setting up all of our attributes that we want to assign to our newly created component. We've got another helper method, create tab content. And this is the method that actually implements that $A create components method that I was talking about in the previous slide. So what this is doing is it's taking the component that we want to create, in this case a cron select component. It's taking the attributes, that's all being passed in, and we then create it using this method, and we assign it to the variable which was tab content. And if you'll recall, it was that tab content which was being passed into the tab list as its body. So as we switch focus between each of those tabs, we're dynamically updating the content to reflect which expression builder we want to show. Now, there's one thing that you've got to be careful of when you're using dynamic creation of components, and that's that you've got to indicate to the framework that those dependencies, it can't look at your code and figure all of those relationships out. So instead, when you define a parent component, you say what the dependencies are. So this is an excerpt, again, from edit schedule job component, which basically says there are 4 dynamically created components: cron select, cron picker, cron day picker, and cron weekday picker. And by doing that, you basically avoid this dreaded error, which when I saw it meant absolutely nothing. It took me ages to figure out. So if you ever see this and you're using dynamic creation of components, just have a think about the dependencies. It's probably that which you've forgotten. And a classic symptom, if you've forgotten it, is you'll see this error, you'll close it, you'll then repeat the same action and everything will work. And that's because it's downloaded the definition after you get this failure message. And what the dependency is doing is it's making sure it downloads that definition up front. Now, another thing that you had to previously be careful of, and this is again something that's made me make some quite late changes to my presentation, was that there was a bit of a bug with dynamic components in that, you know how I said that events bubbled up? Well, they didn't when you had a dynamically created component. The event just disappeared. Either the component could handle it, or you didn't really have any option after that. So this has now been fixed in Winter 17, so it does work as intended. Any component that contains a dynamically created component can now handle it. There's nothing you need to do. It will just start working. But I just wanted to show an example of how I got around this, because it might be relevant, again, in other circumstances. And the way I did that was to essentially assign a reference to a method on the parent component that I wanted to handle in this case, the cron update event. So a cron update event is fired as I change the cron expression. So as I'm selecting those options, it's firing this event so that the parent component can update the cron expression. And as you'll see here, we've got a handle cron update event, and that's sitting in the parent. And again, what I'm doing is sort of wiring the parent and child together. And one of the nice features that I kind of draw your attention to here that I completely missed when I was first developing components is the ability to bind a method directly to an event in a child component. And I'd previously done this without even realizing it. When I'd been using things like the UI button, there was an attribute called press. And that when you press that button, you basically declare a method that you want to handle that. Now, when I looked at the code on GitHub for the UI button, I saw that actually there's no handler there at all. It's literally just a register event, as we've got here, called press. And what I'm doing is I'm passing through a reference to the method I want to handle it. And behind the scenes, Lightning is setting up that handler for me. So I thought I'd just share that information because I don't think that's documented anywhere specifically, but is being used by the Salesforce components that you get out of the box. So onto my last subject, and the last subject is object-oriented design with Lightning components. Now, object-oriented design patterns have previously been available to Apex, but they hadn't really been there for things like Visualforce. And what that ended up with is us re-implementing the same logic on components multiple times. Now, the beauty of Lightning components is some of the concepts of object-oriented programming have found their way into the framework, and specifically encapsulation and inheritance. So what is an encapsulation? Well, it's the process of hiding a component's attributes and methods from the consumers. You only expose to the outside world that which they need to know in order to interface with your component. And what this allows you to do is essentially decouple your components. The provider of a component is free to change the inner workings as long as they maintain the same outward interface for consumers. And then the second one I wanted to talk about is inheritance. And inheritance is a concept which really helps with code reuse. So quite often you'll end up with objects that share similarities. And what you don't want to have to do is redefine the same logic again and again on each different object. You want to be able to say there's a relationship between these two, what's called a super and subcomponent relationship, which basically says, take all of the logic from my super component, and now I'm going to add a little bit more to specialize it. So let's talk about encapsulation in a bit more detail now first. How has that been implemented in Lightning components? Now, what you'll probably observe is that your attributes, methods, and events all have what are called access modifiers. And that's these attributes that are highlighted in red here. And the vast majority of these can take three values. They can either be defined as global, public, or private. So what does that mean? So global means that an attribute, method, event is available in all namespaces. And the way to think of that is if I was building, for instance, a managed package of some sort, when I do that, I create a namespace for it, so it's uniquely identified as essentially mine. And there'll be some logic inside of that managed package that I might want to make available to the outside world. If I want to do that, I need to declare it as global to make it accessible. Public, on the other hand, means that you can only use that attribute, method, or event within the namespace. So if I wanted to use it within my managed package, I'm free to do so, but no one else is going to get to use that. Equally, if I just create it in the default namespace that you get, which is the C namespace, again, that logic will just be accessible to my customizations in Salesforce and no one else. And the last one that I want to talk about is private. So private means that it's of value only to the component itself. It's not accessible to any of the other components that are using it. And typically what you use private attributes for instance, is just to maintain state internally within that component. But you don't want anyone else using it. Onto inheritance. So going back to my scheduling app, when I was walking you through the demo, you probably noticed some similarities between the expression builders. So for instance, the one I've got up on screen at the moment is hours and months. And other than the fact that the labeling changes slightly, the options are very similar. So we've kind of got an every hour or an every month. We've got on selected hours, on selected months, and we've got on interval. Now, the options might change, but fundamentally, they're all kind of doing the same thing. If I take a look at another example, though, if I look at, say, hours and weekdays, if you recall, there were some options that were unique to this tab in particular. So, for instance, on weekdays, we get 3 additional options that aren't available in some of the other tabs. So this is highly specific. So how can we use inheritance to solve this problem and mean that I don't have to write the same logic on each of my expression builders? So what I've got up here is a UML diagram, and this basically is a way of displaying the relationships between components. And what I'm highlighting here is that we've got a set of components that basically what are called extensions of one another. So on the far left, we've got what's called a cron component. And there's 2 things you need to note about this. So this is the root of all our logic. So every single other component that you see in this diagram is extending that functionality, so it gets everything in that. And the other thing is that it's what is called abstract. So what is meant by abstract is that I can't actually instantiate it. It's there for means of sharing logic with all of the other components that extend it, but I don't want anyone to actually use it. So the cron component has some kind of core variables like the cron, the type of cron that we're building, and some helper methods to fire events. But other than that, it doesn't do a whole lot. The next level down, we've got our cron picker and cron select. The cron picker was that component that had like the every, the on interval, and the on select options. So it's adding a bit of logic now. And then if we work further right, we see the cron day picker and the cron weekday picker. And these are extending it even further. So if you recall the last slide, we added 3 extra options for weekdays. And that's where these are existing on the furthest right. So how do we achieve that in Lightning? So this is the extract from the cron component. And there's the attribute that declares it as abstract. So that's telling me that I can't instantiate it. We then have another attribute called extensible. And this is basically indicating that we're going to allow other components to extend it and add additional functionality. And the other part that I want to draw your attention to is that body attribute again. Now, earlier in my slides, particularly with facets, I said this is where any content gets injected into when you instantiate a component and you're not using facets, named facets. Now, it also has another purpose for object-oriented programming. And that is when I extend my cron component, this is the location within the markup where any subcomponent will inject its markup. So to give an example, this extract is the cron picker. So this is the one that gives you the every on-select, and on-interval options. And as you can see, it extends the cron component, so that's establishing the relationship between the two. You'd also notice just on the right of that it too is extensible, so we can add further logic to it, which we did for weekdays and days. And what I'm highlighting now is essentially the markup for this component. And it's this markup that will get put into the cron components in the v-body position. So when you put the v-body in, position it well so that you get the desired results. What else do you need to know about using inheritance? So what is inherited when you extend a component? Well, the first thing is the attributes. So again, this is the cron component, and if I was to think about the cron picker will have access to these attributes. Now, a peculiarity of, I would say, Lightning is that you can't directly access those private attributes. If you were looking at something like Apex, if you were to extend a class, you can just get to all those attributes in the same way as if they belong to that class. In Lightning, it's slightly different at the moment. You need to go indirectly, and a method is provided to do that for you. So this snippet of code, imagine this was in a subcomponent. What I'm doing is I'm getting a reference to the supercomponent, and I'm then accessing its private attributes using the standard set method. If I'd literally just gone component.set cron, that would have failed. It would say, you can't access that. You either need to make it public, or you need to find another way. This is the other way of doing it. You also inherit events. So if, in this case, the cron component has a cron update event, I want every subcomponent to be able to fire the same event. So it's useful here in that we automatically inherit that when we create those relationships. Helper methods. So again, helper methods have a slight oddity. So whilst they are inherited, quite often what you need to do when you're using object-oriented programming is to what is called override a helper method. So think of it in a way that I want to take all of the logic that's in my supercomponent, do the same thing, but add a bit more. And in order to do that, I ideally want to call the version of the helper method in my supercomponent and then provide that extra logic. And after the locker service came in, there were issues with that. Essentially, what was seen in the community is some developers were using API calls that weren't part of the, I guess, the documentation that's acknowledged by Salesforce. So they existed, but people were using them at their own risk. So when those disappeared, it was a problem because the scenario I just outlined where you want to override that logic and provide some extra functionality no longer worked. So what is the solution for that? Because there is a workaround. And the workaround is as follows. So on my supercomponent, in this case, cron, I've basically defined a method called doHelperMethod. This takes two arguments, in this case, name, and then the arguments that I want to pass to that helper method. The implementation that you're seeing at the bottom there basically takes that name and parameters and uses a concept called reflection in JavaScript, where at runtime we basically define which method we want to call by passing in the name in those square brackets that you can see there and applying the parameters to that method. How do we use that? So in the subcomponent, we use that getSuper method again to get a reference to the supercomponent, call the doHelper method, tell it which method that we want to, method to run, and then set the attributes that we want to pass to it. And in this case, we're passing a reference to the supercomponent itself. So in that way, if you need to access the super component's helper logic, this is how you do it. What else do you get? So you also get controller methods are inherited, but the documentation at the moment clearly states that this might not always be the case. So I wouldn't recommend that. I would avoid if you can. And then finally, I want to talk about accessing the DOM. So let's say you've got a couple of components and there's some elements defined, I guess, in your supercomponent that you want to access from your subcomponents. How do you do that? And it's not as easy as it first seems, because like private attributes, those aren't directly accessible. So let's say in my super component, I had a ID for an element called not applicable. If I tried to access that directly, I wouldn't be able to. And the way I get around that, again, is to get a reference to the super components and then do the find indirectly through that. And in that way, I can access that element and then perform some actions on it, like, in this case, setting a value. And that really draws to a close my presentation. So I just want to kind of recap on what we've learned. And that was composition using facets, event bubbling with events, with dynamic creation of event handlers, how we create components dynamically, and how we use object-oriented design. And hopefully I've also showed how new features are constantly being incorporated into Lightning to make some of this even easier. So what I'm hoping is that from this demonstration, from what you've seen, you'll be able to take away some of these concepts, apply them to your own components, and really build some spectacular components that can maybe get on the App Exchange and really kind of help build out this ecosystem. I'd like to just, at the end of this, also say that all of the code that I've shown you today is available on GitHub. So if you want to have a look around, explore in a bit more detail how I've actually implemented this, feel free to have a look, fork it, do what you like with it. It's there for everyone to really learn from. I'd also encourage you to keep up to date with the release notes. Obviously, new features for Lightning are coming in all the time. And Trailhead is an excellent way of learning. So if you don't know about Lightning components, haven't worked with them yet, absolutely encourage you to use that. And it's the way I learn. Developer guide, again, lots of resources. It's constantly being updated. So keep on top of that. And other than that, I'd just like to really thank you for attending this presentation. I hope you've learned something and open the floor to any Q&A. Thank you. Yes. Yes, that's right. Yep. Yeah, so you can access that link, and you'll be able to see all of it, and as I said, have a play with it. Anybody else? Yes.
In the switch app method you use,
Yes.
you are just setting the attribute to the new component renderer.
Yep.
Do you need to delete the other one? So switch from tab.
No, so the question was, when you switch between tabs, do you have to essentially destroy the old component to make way for the new one? Well, I had a single attribute called tab content. And essentially, by just directing it to a new component that I've built, the old component is no longer referenced and will be cleaned up behind the scenes.
Would you mind going back one slide?
Sure. Okay. I'm sorry. But I'm happy to field any questions outside. If you want to talk to me afterwards, more than happy. Thanks.